AKS Office Hours today. For those of you that don't know us, my name is Dave Strabel. I work on the Cloud Native Global Black Belt team as a app innovation specialist. We also have Kendall Roden. Kendall, are you here yet? If not, I think everyone.
Oh. Hey everyone, same role, same team as Dave. So happy to be here.
And if you want to connect with us, you can connect with us on Twitter. I am at Dave_Strabel, and Kendall is at Kendall Roden. So anybody new why AKS Office Hours? Really to provide customers with updates pertaining to AKS and also the cloud native ecosystem. Typically, we start with some updates around that ecosystem and then host a short talk by either people on our team within Microsoft, a lot of times our product management teams. We also like to collect, feedback from customers on issues, blockers, questions you have related to AKS. So today we will do AKS and ecosystem updates. I am going to skip over the AKS updates because there's really nothing notable since we last met here. We will, and Kendall, correct me if I'm wrong here, but we'll have the Azure Arc for Application Services team speaking today.
Yeah, we have with us actually Brian Redmond. You might know him. He is on our team as well and has been working a lot with the team over there. So he'll be talking today.
All right. Then we will try to leave time for the Ask Us Anything. So this is really where you can ask any type of questions you may have related to AKS or anything you're doing in AKS. Just keep in mind, we really want a two-way interaction. So please try to stay on mute when you're not speaking, but feel free to ask questions. If you rather ask them in the chat, we also have a lot of engineers from Microsoft that can help answer these questions in chat. It's primarily hosted by GBB team, but we also have support of PG. We typically try to have someone for the PG to do roadmap updates every couple months here. All the recordings content will be available post-call, so you can find those on our YouTube channel. And as always, if you have any thoughts, ideas, questions, just feedback in general, you can contact us at aksofficehours@microsoft.com. So like I said, I'm going to skip over the AKS.
Sorry to interrupt you, but I think that email, I think somebody gave us some feedback that email wasn't working. So feel free to email Dave and I directly. I'll drop our emails here, but we'll figure that out.
Yeah, perfect. Like I mentioned, I'm going to skip over the AKS updates. There was really nothing notable over since the last time we met. For the ecosystem updates, again, KubeCon will be October 11th through the 15th. The October 11th and 12th is the pre-event programming. So a lot of different projects typically host a 1 to 2 day meetings during this time. I find the pre-events probably some of the most beneficial. Some of them are free. Some of them have a very small cost. Even the ones that cost, a lot of times they're contributing that cost back to different organizations. The main conference is October 13th to 15th. KubeCon this year is slated to be in person and virtual. We'll see if the in-person does work out, but it will also be hosted virtual. The virtual, I think it costs $75 to be able to attend all those sessions. If you don't want to spend that $75, usually a few weeks after the event, sometimes sooner, they will post all the talks and recordings there. So one of the ecosystems updates that came out yesterday was AKS Health Check. This is by a company called Boxboat. They were recently acquired by IBM. It's really a client-side tool that uses both the Azure CLI and kubectl to perform different checks against the Azure data plane, the Kubernetes data plane. So it goes into a lot of checks, and I have not ran it myself, but it is pretty extensive in what it does. This is something BoxVote used to run for their customers, and they recently open sourced the solution. We'll drop a link into the chat for this solution, but it's really easy to get, looks really easy to get started with, and is pretty extensive on the different checks. So from like a Kubernetes side, it's going to make sure that you have things like pod disruption budgets or memory limits set, readiness, liveness type probes. From the Azure side, it's going to make sure you have things, like scale sets. You're going to have different security features enabled, like AAD, those type of things. So I think it does, like right now, about 50 different checks. So definitely check that out when you get a chance here. So Kubernetes 1.22 was recently released. Some of the highlights, in 1.22, there is a pod security replacement. It's essentially now a mission controller that you can either audit, warn, or deny on. So it's going to be, I think it looks like the API is a little easier than actually pod security policies. So that's something I believe that is only in alpha, though. Also, rootless mode containers, so you can run the entire stack in actually user space. Seccomp by default. As you can see, there's a lot of, I think what the Kubernetes project is focusing on now is around kind of security and stability on the platform. Instead of delivering 50 new features in every release, they're really more focused on what they're delivering in each release. And also will support cgroups v2. Cgroups v2 essentially gives you some things like memory QoS, so better utilization of kind of those different resources and resource limits that you may set. Something also notable here is that there's quite a few APIs that have been removed. So not just deprecated. Deprecated means the APIs are still there. You could still use them, but they are in a deprecated state, so no new features or security updates to those APIs. So 1.22 removes, I think probably most notable that people are probably using is probably the ingress API. So you'll want to verify if you have any of those in your current clusters that are using the old ingress APIs. Custom resource definition, if you're running some third-party stuff in your clusters, you need to make sure those projects have updated and still aren't using those old APIs. If you're doing any type of webhook configurations and like for your, like a mission controller for validating or mutation, you need to check those also. All right, I'm going to hand it over to Brian to talk about Azure Arc for application services.
Cool. Thanks, Dave. Let me get my screen shared here. All right. So yes, I am going to talk about Arc-enabled application services. The code name was Project Lima at some point. It really wasn't one of these public code names that we talked about. It was just kind of called that internally. But I like calling it Lima because A, it's shorter to say, but also it's one of my favorite cities I've visited. So let's get into it. Real quick, I think I spoke at one of the early ones of these, but just real quick, who am I? I'm on the same team as Kendall and Dave, the Cloud Native Global Black Belt team. And I've been at Microsoft for 20 long years. My last name is Redmond. It was that since the start. People always get a kick out of that, being that I'm from Microsoft. But I spend a lot of my time doing things outside, biking, hiking, climbing up mountains out here. That's kind of why I live in Denver these days. And I do love to travel. And unfortunately, all I do is sit in this tiny little box of an office in my house. So maybe someday, maybe someday. I'll start with this. I've been working really with containers and Kubernetes for a long time, and I do think Kubernetes is awesome. But a lot of the companies we talk to, it's actually fairly difficult. It seems like it's going to be this beautiful, streamlined process, and then there's so much more you have to figure out. And we see a lot of companies either struggling with it or developing these extensive practices that take a very long time to get to. They write their own open source code. They contribute to the project, and a lot of companies struggle to keep up with that, and they kind of end up here where they're making it work, but they might not even be getting the full value. And Kubernetes only takes care of so much. So we see companies doing cloud native development. It really encompasses all of these things, and probably a bit more if we really think about the teams that are writing the code. Kubernetes helps with a lot of this, of course, but it doesn't necessarily just do it all. In fact, most of the time, you have to roll your own technology for a lot of the things that are a part of DevOps. You have to go grab another tool and hope you can incorporate it into your platform. Certainly not meeting all of the needs of real serious application developers. And we think about developers, we're thinking, probably the most important thing is kind of that speed of innovation. I think Kubernetes helps a lot with the reliability and the security at scale sort of aspects. Multi-cloud, it's okay at multi-cloud, but if I'm a developer, I really don't want to have to think about developing for a particular cloud. I really want something that can help me work across a wide range of environments very easily. And containers and Kubernetes are supposed to help with that, and they do, but they don't necessarily solve everything. And that's kind of why we went down this path of Arc and Arc-enabled application services. Now, probably on a prior session here, I know we've covered Arc, can't remember, but I'm not going to go back and talk about what Arc is. Really, it kind of solves two problems. A lot of the discussions are probably on the left-hand side here in Arc-enabled infrastructure and just using Arc to help manage and monitor and control a lot of different environments across clouds, across Kubernetes, different VMs, and so forth. To me, the interesting part of Arc that I like is where on the right-hand side, where we're doing Arc-enabled services. We're basically taking some of the best services that we have in Azure and using Arc to push those down to environments that aren't in Azure, whether that's different clouds like Google and Amazon, whether it's your private cloud data center, some edge environment, really anything that can be Arc enabled, you can then start to run those as custom locations, which I'll show you in a demo here in a bit, and deploy services like SQL Azure, PostgreSQL, we have Azure ML, and of course, these application services, a lot of our PaaS services that we have in Azure can now be run in any kind of Arc-enabled environment, which is pretty exciting. So this is kind of a high-level view of what Arc-enabled application services is. I do hate saying the whole entire title. I guess naming is hard. But right now we're in public preview, and these are the services that you see there. I would imagine this may grow. This is kind of what we started with. So we have our Azure App Service that can run in an Arc-enabled environment. We have functions and logic apps. Probably most people are familiar with these platforms. Obviously, functions is event-driven, serverless code. Logic apps is similar, but more of a workflow tool, step-by-step kind of connectors to process data in some sort of application. We also have the ability to run API management. So maybe our environment, our Kubernetes cluster is running a series of APIs. I'll show you this in our demo. Maybe we want an API gateway sitting in front of them, but not in Azure, outside in some sort of edge environment or some other cloud. And then we also have Event Grid. And so if we have events that we need to subscribe from a number of different sources and be able to make those available, not necessarily only in Azure, you have the ability to run Event Grid very easily in an environment without necessarily having to kind of figure out how to deploy some other kind of technology. Arc will take care of all that work for you. So I want to talk a little bit about why we're doing this, because I think a lot of times people see this and it's almost surprising. I think the first few times I've talked about it to some customers, there's this almost look of confusion when they first hear about it. The first why of this is kind of what I was talking about at the beginning. Kubernetes is difficult. It's not PaaS. A lot of people want to call it PaaS, but it most certainly is not. And it's not identical from cloud to cloud. Certainly one of the reasons I think Kubernetes took off is that portability of knowing that I can run Kubernetes anywhere and it'll be the same. It's mostly the same, but certainly GKE and AKS and EKS, they're a little bit different. And so you still have to almost migrate as you move from cloud to cloud. And that can be fairly difficult. It's really great at resource scheduling, but there's not a whole lot being done to help developers. There aren't really primitives that are super focused on a complex application. There's been a number of attempts, some more interesting than others, but nothing that's really deeply integrated and took off. A lot of times we talk about Kubernetes, it's all about networking and security. Almost all of the conversations. And when you want to do things that are more developer oriented, you got to go out and grab some tool or kind of roll your own solution to take care of it. The other thing is just having that consistency and portability. I am a huge fan of our Azure PaaS services, but they only run in Azure, and there are a number of scenarios where someone might still want those services, but not be able to run in Azure. You know, data sovereignty is a common example. Maybe they have sites that are running. They need data in sites where there isn't Azure, something like Russia or the Middle East and so forth. But you still want to take advantage of Azure. Great opportunity to use this solution. Certainly, edge and branch scenarios. We think a lot about using this in a retail scenario where I might have connectivity, but I've got to be able to run things locally in the store or local branch. I could use this and still get Azure PaaS services on top of it. And so there's a number of places where this would be super helpful in that kind of scenario. And it's not really a new concept. There's a number of different areas where people have developed another layer of abstraction that runs on top of Kubernetes that helps me focus on a particular kind of workload, like machine learning. There's a number of open source projects like Kubeflow that instead of trying to deploy some machine learning workload on Kubernetes, I can actually deploy an actual resource called TensorFlow job, for example. And Kubeflow will take care of the inner workings of what that actually looks like. It may not necessarily just be some pod or job. We may be able to actually incorporate all the ML sort of functions into it. And gaming, and we've seen a lot of this around functions, including this Azure Functions. But OpenFaaS and these other solutions help you run functions on top of a Kubernetes environment, which of course you could still do natively, but this makes it way easier to focus on that particular workload. So from there, I think a lot of it makes more sense when we do a demo, and I'll certainly take questions at the end. But before I go into the demo, anybody have a question on your mind right now? I'm going to glance at the chat. Okay, well, this is the demo we're going to walk through. This is basically a drugstore type customer, and they have a bunch of store locations all over the world. And of course, they run their corporate applications centrally in Azure. And so they run AKS, and they have a series of microservices for managing orders and accounting, data stored in SQL Server, Cosmos DB. They front end all of those services with APIM. They have applications running in app service. And you can imagine, you know, even though they could run all of this in AKS or all of this in app service, that's often not what we see. We see companies with some teams building container-based microservices, some teams building web apps in a PaaS sort of type model. So it's a mixed environment like that, and it's commonly what we see. But out in the store, the customers can use any Kubernetes. So they may be using something like Rancher, Red Hat, whatever it may be. They want that same ability to be able to actually run some of these things. So in this case, they're running some of their services in that local Kubernetes. Some of the same services you can see there are actually the ones that are running up in corporate. But the backend services are open source things like RabbitMQ, Redis. They're using local file storage, and they are using Arc for running SQL database. So they get that consistency via Arc to be able to run SQL in the public cloud and SQL Server in their store location, but it runs as a pod, but it's managed by Arc and kept up to date and controlled in that way. They still front end all of that with APIM. So APIM is actually delivered into this environment with this Arc-enabled application services. And then you can see this app service Kubernetes environment. That's essentially our PaaS platform as a control plane dropped into the cluster. And once they do that, we end up with this store having what we call a custom location. And now I can do web apps, function apps, and logic apps the same exact way I do in the public cloud. I just pick this location instead of one of Azure's locations. That makes it really easy to keep these things running locally, but still take advantage of Azure's APIs to deploy and manage them. So let's jump out and take a look. So first of all, I'll show you these web apps just so you can see what we're dealing with. I've got this headquarters corporate dashboard that shows me my store sales over time. We show 6 of the stores here, Denver being the one that we'll actually go in and take a look at. But this is running in straight up Azure East US. The data is stored in SQL Azure in the public cloud. So nothing really special about this dashboard. It's the Denver branch where I live, where we see something a little bit more interesting. This is the one that's running actually in the store, and we see the order queue. These orders need to be fulfilled. We actually can see all the items that need to be picked up, and we see some detail about how our store is performing in that local branch. And these branches lose connectivity, and if they don't have connectivity, they can't even process orders. So that's why we take advantage of making sure it can run locally in the Denver site, and we can still do what we need to do. But of course, we use an Azure function running in this site to actually grab these transactions when they're completed and push them up to Service Bus, so that we really do have all the history stored in the public cloud. But in the sort of time while they need to be processed, we have them locally, and we can continue to function no matter what. So if we take a look at my Azure subscription, I've got a couple different resource groups here. First, we'll take a look at Corp. And again, this is all typical Azure stuff, nothing really new here. I'm running all these services on AKS, so you'll see a Kubernetes cluster. But I'm going to show you just real quick from an app service standpoint. Again, this has been around for a long time. App service has been in Azure since the early days. And so we built out a lot of functions that you can manage of this environment right in Azure. Of course, we're looking at it in the portal. It can all be done by RM APIs. But if I want to scale up, scale out, I want to do things like deployment slots that help me promote things from maybe test and QA to production in an easy way. These things, I don't have to really think about the infrastructure. I do all of this just with Azure PaaS. So fairly powerful in managing web applications. Where it gets interesting is when I come out to Denver, we take a look at the resources we have here. This is where you'll see some new things that are a part of this public preview. First thing you see is we have this app service Kubernetes environment. So when I deployed this, I ended up with this resource. And if we look at the actual cluster itself, when I actually went and deployed this, I end up with this set of pods. Essentially, I think of it as the app services control plane that is running in my cluster. And so there's a series of things that take care of deploying the app, that take care of networking and routing, and you'll see all those pods if it ever comes back here. And so you can see we've got logging. Envoy is actually used to proxy traffic to the particular apps. And you can see my apps here, which we'll take a look at here in a second. But the one thing you'll notice is we have this Contoso Denver. And so this is that custom location. It represents that Kubernetes cluster that's running out in that Denver site. And what's really cool about this is I can say, I want to deploy a new web app. Say create. Obviously, I could pick any one of the Azure locations to run this in. When I pick region, I see this big list of typical Azure regions. But what I see here that's kind of cool is I see Contoso Denver. So wow, I can just deploy right to this environment using a normal Azure portal screen here, or even ARM or CLI, and deploy right to this environment. When I do, I actually end up with these pods that represent that. And obviously, if I want to deploy these myself in Kubernetes, I could deploy this dashboard into that environment. And this is what the developer has to start with. And they just start typing, right? In reality, we paste in some other YAML file. It's fairly cumbersome. I mean, YAML, like I feel like I'm a YAML application developer at this point, spending so much time in Kubernetes. In the end, this is certainly not developer friendly. and not a great way to do things. Instead, we're going to focus on building them out this way. I'll show you what this ends up looking like here for one that's already deployed. So we take a look at this app service dashboard. And you can see, we see pretty much all of the same things we saw in the corporate dashboard running in Azure. But again, this is running in Contoso Denver. And so when I click on things like deployment slots, I can do the same sort of thing that I did up in Azure, but I'm actually, when I do a deployment slot, I actually end up with another pod. So you can see I've got prod and testing. The prod slot are these two pods, and the testing one is this one. And the reason you see 2 for prod is in the scaling settings, I set this at 2. Obviously, it's not super difficult if I had some sort of Kubernetes deployment to scale it out and in. But you can imagine I'm now starting to take advantage of things that I can do in Azure, which are fairly extensive, but I can do it on top of this Kubernetes cluster without having to necessarily figure out all of the inner workings of a Kubernetes cluster to do it. I have the same thing from a function standpoint. So I have this function running here. This is the one that will take orders that are processed and push them up to corporate via service bus. And you can see I've got a couple different functions here. We can click on one. We can actually see all of the monitoring and execution details of how things are performing. I can even go in and click on monitor and see live logs. And I think this is actually super cool. It takes it a second to light up here, but as a developer, someone says this function isn't working. I mean, this is what they would have to do. They have to go in and take a look at the logs of this pod. It's going to ask me what container I want. And you can imagine that this is just a painful experience for a developer. And obviously I could go in and mess around with this, but instead I actually can see this right in the portal, and really a lot of different ways I can see all of this. We're using App Insights and Azure Monitor here to actually do this, but I can actually see right here what's actually going on without, again, having to even have access to the Kubernetes cluster, much less learn how to do logging and testing and so forth. So I love having that ability to do that. And you can see more things will get added here. I'm not using Event Grid and APIM in this particular demo, but I think at that point you get the idea. So I will come back and we'll take questions. That's really all I had from a demo standpoint. Again, the idea is take the things that you do in Azure, our PaaS services, again, starting with these, but run them anywhere, anything that can be Arc enabled, whether that's multi-cloud, whether that's private cloud, edge, and so forth. So I will stop there and stop yapping and take questions. Any questions, whether they're about this or other stuff, happy to talk.
So this is very impressive. I just posted also a question in the chat. What is the requirement for Linux and Windows? So I have some web app that I'm running right now, and this is actually outside of the Kubernetes, and it seems like now you can run Windows web app inside of Kubernetes that you just demoed. So what's the requirements for mixed environments like that? What's the patches?
Great question. So this actually is starting with Linux containers. So in app service, you can run Linux and Windows workloads. In fact, app service probably was more Windows centric than Linux. For the Arc enabled application services, we're actually in the reverse. We're starting with Linux containers, or at least if it's a container based workload. If it's just code, then it really it matters more about whether the code can run. If it's just a .NET web app, then we need to make sure it's actually supported in that environment. But yeah, it's a good question. I think eventually we'll be able to run both kinds of workloads as long as the Kubernetes cluster itself supports both. Any other questions? Quiet. Group's quiet today.
I would be curious if just anybody has thoughts on this. What, do you see this being useful? I mean, do you have thoughts just on your initial I don't know, just your initial takeaways. I'd be curious just if people have any opinions on it, good, bad,
One question I've got, does it work with ingress controllers and stuff like that? So you can put some web application firewall in front of this?
Yeah, that's a good question. Yeah, because in theory, like if you want to go down the route of kind of doing all of the steps and picking the ingress controller and picking how you do everything, then you're probably actually better suited to use native Kubernetes. In this case, all of that is typically things that are solved by the platform itself. So if you use Azure Web Apps, it has security, it has routing, it does all that, and we do that in Arc enabled application services. You kind of saw Envoy there, that takes care of some of it. I think that's also a reason why APIM is a part of it. Great way to put that in front of the applications that are running there. But yeah, if you want to kind of pick your ingress controller, that's interesting feedback. Yeah, we may want to understand that more and understand, hey, can I put something in front of this in between what we do?
Yeah, I'm just sort of thinking, like, you got your IT ops team, your platform team who set up all the AKS clusters and set up the ingress and everything, and then you got your dev team who are using the Azure portal to put their container onto it using the tools they're familiar with, like the Azure portal. So you'd want something there to make sure it's secure 100% and not just being distributed through random IPs through load balancer or something like that, potentially.
Yeah, it's great feedback, and yeah, you can see we're actually working on trying to figure some of this out. You can see here, like this web app I deployed. I'm not sharing. I'm realizing right now, but it's not really worth sharing. That when I deployed that Denver dashboard, I ended up with a DNS name for it that was some big long thing that actually pointed to a public IP address on my cluster, and that's where we are in the preview. You need a public IP and you route all the traffic. We set up DNS for that. It all comes to that IP address. In the long run, we know that's not feasible. Like most companies aren't going to just use a public IP for the cluster and let it all work. And so we're working through that part. And I think what you're describing, we need to incorporate into that.
I have another question. It's similar, but I think it's nuanced to that. So it's a two-part question, really. So one of them is the idea that for us, we heavily use both of these services, but mostly from a numbers perspective, we use more absolutes. We found that the service mesh is the primary rationale that benefits using something like Kubernetes, right? I'm not going to go down the rabbit hole of what service mesh. That's not my point. But I mean, is there an assumption that if we would be using your native service mesh, which is also in preview, that would be applicable, or is there like, what's the point? Why would you be doing app service? The second one is sort of related to that, and it's what's the end goal here? Because there are benefits to using app service. You called them out, and there are needs to use AKS, but you've also called out the imperfections in the model. I don't know what else to call it. So is the idea that you're able to mesh all of these together, or are there just too many conflicting requirements to have that happen? I don't know. That's kind of my thoughts.
Yeah, I'll answer the second one first, because the thing I think about it is I think when people hear about these things, they think, okay, this is supposed to be the answer, and therefore it's Microsoft's answer for everything. And I I definitely don't think that. I think that one of the beauties of this is it kind of solves some scenarios where the other two didn't fit.
Okay.
But the other two are still great solutions, and we're going to see those grow probably faster even than this. So I think it's super helpful in a few different scenarios, but I don't think it's the thing everyone should just kind of drop everything and use. Like I said, some companies are doing great work in sort of building a Kubernetes practice, and that actually is a great way to do things. But the ones that are struggling, this could be great. Or again, the sort of the other scenarios where I need a platform running outside of typical Azure. The first question, I mean, I look at it as, do you need a service mesh, or do you need the functionality that service mesh is doing? And if we can't meet the needs of what you're doing with that service mesh with our app services, then we need to do that. Let's say it's distributed tracing, monitoring, it's TLS security. We've got to meet all of those requirements in the platform. So you don't need a service mesh.
I like this as it is. It's the capabilities. It's not me. No one loves installing Istio and managing it. Trust me. But the idea is there's capabilities that we.
Yeah.
And then that was sort of my question, because I do think that what you're solving for, though, is the idea that what our developers love about app service is that it is truly easy. If they're using a managed runtime and you're not using a container, and we actually find that to be pretty successful in app service for a few reasons. You just care about your code. That's all you care about, right? I don't, even if you're using a container, it's not really that big of a lift. I'm not really saying that containers are bad by any means, but there are a lot of productivity advantages, and you call them out, right? So how can we get more productivity out of the Kubernetes platform, even if we don't use something like Arc? That's sort of where I'm trying to get at, Brian. Do I need Arc to get some of those benefits, or can I start getting some of those productivity benefits without Arc?
Yeah, and we're kind of proposing that some companies are going to need some other abstraction layer there to help, and that's why this is effectively a solution that could be helpful. But again, there could be other ways to do it on native Kubernetes, and again, some places are getting better at it than others.
Thank you, I appreciate it.
Hey, I have a question regarding to hosting Windows container in AKS. I had a scenario that I built an old .NET 4.7 container, which is like a 6-7 gigs. How do we host this such big Windows container in AKS? Is it really good to do this, or what's the best practice for hosting Windows container?
Oh boy. You said 6.7 gigs, I think. That scares me. No, I'm sometimes fairly frustrated with Windows containers. I do believe that there's a purpose, but I often struggle when that's the scenario that you kind of end up with, because then you lose some of that sort of benefit of the sort of nimble kind of nature that containers give you, and you just get these giant Windows images. And then I think, okay, well, maybe that code could be running in .NET Core. That might make it smaller, and you could use a smaller Windows base image. But then you do that, and then why not just make it a Linux container? So
Yes.
I think if Windows is what you need, luckily we do support Windows containers, and you add that to your AKS cluster. But I'm not the best person to kind of talk through about how to do it effectively. I don't know if anybody else wants to chime in there.
Where I currently work, I've got one of my customers, and we have the same web app kind of thing. And I think we're actually moving from app services, web apps, to AKS with this customer, because we have about 450 different instances of it running for all their customers. So actually, we containerized it because I didn't want to do any code changes. One image, web configs are done through app configs, and then we inject that into the image, so every one can be different. Container startup time, and then it just auto scales based on resources. You set your resources and your limits correct, and it's all good. It works really well.
Yeah, that's good to hear. Yeah, and I know we do have a bunch of customers that are using it. It's not nearly as big, of course, as Linux and AKS, but there are those workloads where it makes sense. And you can see Steve Griffith put in the chat here on Teleport. There are things people are trying to do to help and make it easier.
Yeah, Project Teleport is trying to help solve that problem, like knowing that these container images can be pretty massive. I mean, the first thing you can try to do is see if you can move to like the nano server image. If you're using, the larger image, that might save you a little bit. Nano server is still fairly large, and once you get all your tools in there, it can still be pretty sizable. But Project Teleport effectively mounts pre-expanded images to your cluster, right? Expanded and mounted in some ways is like an NFS share. You can see the details on it there, but that will greatly increase the speed of container start for those large images.
Do we know when the Windows support's coming for that? Because last time I heard it was only going to be for Linux containers, because of like the machine learning AI size containers are huge.
Yeah, it's going to be as quickly as possible. We don't have the specific date on it. Is it mentioned in that issue there? Yeah, I think it's still pending, but one of the main use cases is for Windows containers, so it should be pretty quickly after.
Cool.
Awesome. Are there any other thoughts or questions that anybody has today before we wrap and give you back 20 minutes? All right, awesome. Well, hey, Brian, thanks so much for coming. This was really informative and definitely think what did a really good job kind of framing up the story of why this is important. So thanks all for joining. We look forward to seeing you next.